our lab partnered with the New Mexico Space Grant to take a look at the design of interfaces for robots which operate at multiple different levels of autonomy. Currently, NASA is developing a robot for use on board the International Space Station called Astrobi. Astrobi helps astronauts and guest scientists with research and maintenance activities aboard the ISS. And one neat thing about Astrobi is that it can operate at multiple different levels of control. For example, it can perform its own tasks autonomously, but it can also be teleoperated, either by astronauts on board the station or by researchers back on Earth. So this provides Astrobi a lot of flexibility as a platform. However, moded systems tend to come with some drawbacks as well, including an increase in mental workload, higher stress, and a greater chance of committing errors. So, we decided to tackle this challenge by developing an interface for a moded robot that would communicate its current mode through a constant visual display, while also notifying the user of any mode transitions through audio announcements. Right now, we are testing this interface with a model of Astrobi we created, which is an iRobot connected to a Raspberry Pi with a tablet mounted on top for that interface display. And we're testing this inside a model of the workspace, which is a lab room we took and plastered the walls in giant prints of the interior of the ISS. Here we set participants as a team with our model robot to complete a series of tasks which all play into this fiction of repairing a space station. And key to their success here is switching their robot between 3 separate modes. In user command mode, they can command their robot to drive to another room, fetch them a tool they can't access, and bring it back to them. In mission control mode, they communicate with mission control through the robot for help unscrambling codes that they can input into a Unity program we created for this experiment. And then finally, we have them switch their robot to autonomous mode when they're not using it, so it can work on completing its own repairs. Right now, we're testing this within subject's design. So for half of the study, participants work with Astrobi with that audio-visual interface, and for the other half of the study, they have no mode feedback at all. And throughout, we're tracking participants on their time to complete the various tasks, the mode errors they're committing, and surveying them on their level of trust in their robot and their situational awareness. So while our data collection is still ongoing, we have hopes to continue this on as a series of studies. For example, we'd like to team multiple participants with one robot, so another participant might change the robot's mode, and you might not be aware of that transition until you have to work with it as well. And while we took a look at this one use case of space, we have hopes to create design guidelines that would carry out across multiple industries. For example, in healthcare, you can imagine an interaction with a robot where you can have a basic conversation with an onboard operating system, but then you can switch it to a telepresence mode to Skype a doctor in for a more detailed consultation. So that's our design as it stands right now. I'm looking forward to getting feedback from my fellow pioneers.